Alright, hello and welcome to today's lesson. This is Mr. Ludden, and today we're going to have a look at the specific types of numbers that you will be dealing with not only in your Junior Cert but in your Leaving Cert as well. As always, any of the key points that I make in this video will be in the description below, and if you check out the comments below as well, I'll have one where there'll be a timestamp of each of the topics that we go through today, so if you want to skip ahead you can. The first thing we're going to have a look at today is what these words in front of you actually mean. Then we'll have a look at where they come up in your log tables, and finally we'll have a look at 2 exam questions from Junior Cert higher level that deal with these 4 words specifically. So starting off on these 4 words, now these 4 definitions, whether you know it or not, you have come across all of these things, whether in primary school, first year, second year, or third year. But right now, our main job is to be able to distinguish between the 4 of those. So it's just getting our definitions rock solid. So we'll start off with our natural numbers. Our natural numbers are denoted by the letter N. So N for natural numbers makes sense. And these are all your counting numbers. So if you were to imagine if you were to count something, you'd start off with a number 1. You go 2, 3, 4, 5, and all the way up until you finished counting whatever you wanted to count. These are your positive whole numbers if you were to sort of describe these perfectly, and these can be described as a set of numbers as well, so the set of positive whole numbers. I will be doing a video on Venn diagrams and sets, but in maths, if you are to describe something as a set, the way you can do that without writing it out is by your brackets. So if you put squiggly brackets each side of that, what you're telling me is that your natural numbers are the set of numbers that starts at 1, goes up 2, 3, 4, 5, and I wrote ... to signify that that goes all the way up to infinity. So your counting numbers all the way up to infinity. You'll notice that 0 is not a part of those, because for the reason that if you were to count something, you wouldn't start at 0. It makes no sense. So fairly straightforward, I think. Next step is our integers, and our integers are like our natural numbers, except they take into account the negative whole numbers as well, and also 0. So I'm going to start with 0 in the middle, and I'm going to write out all my natural numbers. So 1, 2, 3, 4, ... all the way up. But our integers also go all the way down as well, so they take into account our negative numbers. -1, -2, -3, and so on. So the only difference between our integers and our natural numbers is our integers takes into account our negative whole numbers as well, and also 0. The one thing about integers, when they come up in exam questions, they'll be denoted by the letter Z, and that comes from the German word Zettler, which means numbers, and that's the letter that's given to our integers. So just something to be aware of. If the question says that a number is an element of Z, you need to know that Z means integers, and there are your positive and negative whole numbers, including 0. Okay, another step up to your rational numbers. Now your rational numbers are anything that can be written as a fraction. So I'm just going to move to a different slide here, blank one, just to give you some background information on that. So your rational numbers basically can be written as a fraction. Now the thing about fractions is, if I was just to draw a box and the line of my fraction and a box here, my 2 boxes, they have to be whole numbers, because that's the way fractions work. You can't have like 3.1 all over 7. You can't have that because you cannot have a decimal point as either your numerator or denominator. So this will not work. So if you think about the numbers that we've done before, so the numbers that have come up, let's say the number 5. You might think, well, 5 can't be written as a fraction. But if you think about it, 5 is the same thing as 5 all over 1. And if you think about that, 5 is a whole number, 1 is a whole number. So therefore it is a fraction. Now, we would never write 5 as 5 over 1, but this is just to show you that it can be written as a fraction. You'll notice that all your other fractions that you would have come into contact with, like let's say a half, a third, let's say something like 3/7, these are all rational numbers as well. These all work for your rational numbers. So you'll notice that like there's a lot more rational numbers than integers or than natural numbers, because there are so many fractions, let's say even between 0 and 1. Like there's a half, there's a third, there's a quarter, there's a fifth, there's all of those numbers. And also your whole numbers are rational numbers as well. So for my rational numbers, I'm just going to put down a few here that will work for you. 0 is a rational number. It can be written as 0 over 1. 2 is a rational number. It can be written as 2 over 1. If we go the other way, minus 1/3 can be written as a fraction. Minus 10 all over 1, which is just minus 10, and so on and so forth either way. So your rational numbers, if you think about it, include all of your integers and all of your natural numbers as well. And the only thing that we're including in there are your fractions. And the only thing you have to be careful of with your fractions is that your numerator and your denominator are both whole numbers. You'll notice that your rational numbers have a Q as the letter that represents them, and Q comes from the word quotient, which is a fancy way of saying division. And if you think about fractions, well, if we just go back here, 5 all over 1 is the same thing as 5 divided by 1, and quotient is a word used, as I said, just to describe something being divided by something. So again, something that you're going to have to become familiar with. If you see the letter Q in a question, you'll know that you're dealing with rational numbers. The last thing we're going to have a look at is your real numbers. And your real numbers is everything that we've seen before. So your rational numbers, integers, natural numbers, but also something called irrational numbers. So IRRATIONAL, irrational numbers. And irrational numbers, you might have guessed, are numbers that cannot be distinguished by fractions. So let's put down a couple of examples. Again, it's going to be the set of numbers. 0 is going to be there. 1 is going to be there. So 0 is an integer, 1 is a natural number. And let's put in another rational number. 3 over 2, which is 1.5, which will be a rational number all the way up. And you might have come across, if you've done area and volume, you might have come across pi. And again, I'm going to just go back to my rough work page here. I'll just take away these. Pi is, if you put it into your calculator, 3.14159, and then I think it's either 26 or 62. It keeps going on. So if it keeps going on, and if these numbers here don't repeat themselves, that's what we call like a never-ending decimal, or a better way of saying that is an irrational number. So pi is an example of a real number that isn't a rational number or an integer or a natural number. Also, E, if you find that on your calculator and if you press enter, it's like 2.71, I think. But that is a decimal that keeps on going as well. So pi E, I'll just put them in right order. So I'll E pi, and also like your negative, like negative pi, negative E, let's put that first, and negative pi are also real numbers as well. So the only difference between your real numbers and your rational numbers are these guys. And there's a whole load of different irrational numbers as well, but the most popular ones are pi and E, and you will come across those throughout your maths course, not only in Junior Cert but in Leaving Cert as well. So just to recap, your real numbers are any numbers that you can think of, so positive, negative, whole numbers, fractions, numbers that can't be written as fractions, anything you want. Going back up one, your rational numbers are your numbers that you can write as fractions, and that includes your integers and your natural numbers. So moving on to your integers, remember that they're your positive and negative whole numbers, and your natural numbers are your positive whole numbers. Something to be aware of, all your natural numbers are included in your integers, all your integers are included in your rational numbers, and all your rational numbers are included in your real numbers. So each one of those is a subset of the other, or a smaller part of the next one. And oftentimes we can signify that as subsets of each other. So just writing what we said there just a different way. If I took my innermost circle here, that would be my natural numbers. And if we took, so let's say inside this circle here are all my natural numbers. If we went to the second circle here and called it our integers, well, we can see that all my natural numbers are inside the bigger circle of my integers. If we go out one more layer, we know that if we call that our quotients or our rational numbers, we can see that all of my natural numbers are inside my integers, and all of my integers are also inside the group of my rational numbers, which are my quotients, my quotient numbers. Finally, at the very end, the R for real numbers, that it takes into account everything we've looked at. So my real numbers take into account my rational numbers, my integers, and my natural numbers, which is exactly what I've said here with my arrows. But the way I've put this is for this sort of demonstration is because in an exam question they're fairly fond of asking something like this. So it's very beneficial to just become familiar with what's in front of you here. Okay, that was an introduction to all of these numbers here, and it will help you if you learn what those numbers actually mean. But if you forget, or on the day of your exam you just want to make sure, you do have a backup, because on page 23 in your log tables it tells you about your natural numbers, your integers, your rational numbers, and your real numbers at the bottom of that page. So your natural numbers are your whole numbers starting at 1 and all the way up. Your integers, it's gone from -3, -2, -1, 0, 1, 2, 3, and all the way up to infinity, and all the way back to minus infinity. For your Q, which are your rational numbers, small bit more things to worry about here, or to take into account, I suppose. It's written as a fraction, where P is an element of Z, so P is an integer, so the number up here is an integer, and also Q is an element of Z, so that means Q is an integer as well. and q can't be 0. So that's a long way of saying that my rational numbers are fractions where the top and the bottom number have to be whole numbers, and the bottom number there can't be 0. So q can't be 0. The reason q can't be 0 is because if you have a fraction and if q is your denominator, your calculator will not be able to do it. You cannot divide by 0. So this bit here is just your terms and conditions of what your fraction can look like, and this are telling you that your denominator and your numerator and your denominator have to be whole numbers. So as I said, it's helpful to learn those off, but if you are stuck or if you want to just make sure, page 23 of your log tables has got your back. Okay, we'll have a look at some exam questions, and as I said before, this sort of diagram came up in 2012, and this question was worth 20 marks here. So we'll jump straight in, and I'll just tackle the A part first, and then we'll have a look at how we're going to tackle the B part. So just to point out something to you with the marking scheme, just before we start, the whole thing there was 20 marks, and you might think, well, oh, the B part is a huge part here, so that must be worth like at least 10 of the marks. But if you look at the breakdown, the A part here is worth 15 marks, and the B part was actually only worth 5. So it's worth noting that sometimes the marks aren't distributed as you might think. So if you were to take one message from that, it'd be never leave any question blank, because there could be quite a lot of marks going for it. So we'll start this question. Give 2 reasons why minus 7.3 is not a natural number. If we go back to our definitions up top, our natural numbers are positive whole numbers. So positive and whole numbers. So let's get back to that question. Well, first of all, minus 7.3 is not positive. That's one reason it's not a natural number. And minus 7.3 is not a whole number. So that question there for 15 marks was just wondering, do you know what a natural number is? And can you tell me 2 reasons why that is not a natural number? Even if you weren't sure, you probably could have guessed at it, but that's a very, very easy 15 marks to get, and also it's a very, very easy 15 marks to lose if you didn't know your definition there. That's the reason learning your definitions is so important. So that's 15 marks got already. We'll have a look at the marking scheme in a little bit, but this question here is what I wanted to concentrate on. This is what I'm most interested in. So what we have to do here is represent these numbers down here at the bottom on this diagram here. So you might be asking, well, where would I start in a diagram like this? Would I start from the middle and work my way out, or would I start from the outside and work my way in? And if you think about this, like your real numbers, it's the big set here on the outside, that takes into account all of my numbers down here at the bottom. So the minus 8, pi, 1/3, 6, root 2, minus 4.5, and 7 to the power of minus 1. So we know that like all of these numbers are going to go in this diagram here somewhere, but we want to find out the exact place, the best place for these numbers to go into. So what we're going to do in this situation here is we're going to work from the outside in, and we're going to see where is the innermost circle that we can put each of these numbers. So we'll start with minus 8. And minus 8, we know it's a real number. We know it's a rational number because it can be written as minus 8 all over 1. We know it's an integer because it can be written, it's a whole number. Even though it's a negative, if we remember back to what our integers actually were, they can be negative whole numbers. So if we keep going in one more circle, is minus 8 a natural number? If it is, we can put it straight in there and happy days. But if you see anything about minus 8 that makes you question whether it is a natural number, we cannot put it inside the innermost circle here. So you might have guessed it, minus 8 is not a natural number because it has a negative sign in front of it. However, it is an integer, so we're going to put the minus 8 in here. It is an integer, but it's not a natural number. And just with our integers, z and our natural numbers, just to concentrate on those, just to concentrate on that little part of the diagram that we had. The minus 8, if I put it in this part here, it tells me that it is part of the integers, but it's not a natural number. It's outside this circle here. So I'm hoping that that makes sense, that right there is the place where the minus 8 is going to go. So we have minus 8, we're going to stroke that off so that we know that we've done it. And the next one we come to is pi. And again, we start our process again. So pi is a real number, but in our next step, is it a rational number? And it's not, because pi as 3.14159 ... cannot be written as a fraction. So we cannot put it inside this circle here. So that was a quick and easy one, I suppose. Pi is out here. Pi is a real number, but it's not a rational number, so we cannot put it in the Q circle. So I'm going to put a line through that. 1/3. 1/3, as always, for each one of these numbers, we work our way in towards the middle. It is a real number. It can be written as a fraction, but it's not an integer. So we can put it inside the circle with denoted Q, but we cannot put it inside the Z circle because it's not a whole number. So 1/3 is going to go here. Six, again we start, it is a real number. It can be written as a fraction, as 6 over 1. It is an integer because it is a positive or a negative whole number. And let's see, is it going to be our first natural number out of this list? And if you think about what a natural number is, it is your counting numbers. So 1, 2, 3, 4, 5, 6, there we go. 6 shows up in my natural numbers. So 6 is going to go in the middle. Okay, halfway there. Root 2. You're going to need your calculator for this one. And if you put root 2 into your calculator, just take pi away there. Root 2 is going to be 1.414. It's something along the lines of that. But the main point of this is that it goes on forever and your calculator will not change it to a fraction for you. So 1.414 on and on and on is a real number. And I'll just take these check marks away. It is a real number, but it cannot be written as a fraction. So my root 2 is going to go in my outermost circle, but not in the circle that's next inside, or the set, I suppose, to give it its proper name. So root 2 cannot go inside the circle here because it cannot be written as a fraction. You might say, well, why can't it be written as root 2 all over 1? That would be great if root 2 was a whole number, but root 2 is not a whole number. It's 1.414 blah 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 blah. So it cannot be written as a fraction. Okay, minus 4.5. Minus 4.5, just something to be aware of. Minus 4.5 is the same thing as minus 9 divided by 2. If you divide 9 by 2, you get 4.5. So it might be something, so this and this are the same thing. So it might be something to keep an eye on. And again, minus 4.5 will be a real number. A real number is anything that you can think of at the moment. It can be written as a fraction because we just have minus 9 over 2. But again, it's not a whole number, so we cannot write it as an integer. So again, it's going to join 1/3 here, and let's put our minus 4.5 in there. Okay, last one, 7 to the power of minus 1. And this takes into account our indices. So I will put a link into the video that I did about indices a while back. I'll put a link to that in the description. But very quickly, 7 to the power minus 1, if you put that into your calculator, you will get 1 all over 7. So if you were to think about where 1 over 7 would go, or 1/7, well, it is a real number. It can be written as a fraction because we're just after doing that on our calculator. And again, it's not an integer because it's not a whole number. So again, this is going to join my 1/3 and my minus 4.5 in this part of the sort of diagram in front of you, and 7 to the power minus 1 is going to join it there, and we'll write that out. We've finished this question. We'll have a look at the marking scheme in 2 seconds, but just a sort of key point here, your calculator will help. If you didn't know what like 7 to the power of minus 1 was, if you wanted to see what root 2 was, if your calculator gave it to you as a fraction, and if you wanted to see what pi was, etc. So your calculator will help you in sorting out, or so I suppose giving you clues about what those numbers, those tricky numbers, actually are, because that question, some of the numbers were sort of disguised there. So, marking scheme, as I said, first thing here was 15 marks, and the next one here was 5. And as you can see there, if you want to pause the video, you can see what the marking scheme says. But seeing as I've walked through it all, and it basically says the exact same thing that I've said, I'm not going to spend too much longer on that. The second and last exam question that we'll do, this question came up in 2017 and was a part C of a question, and it asks you about different types of numbers again, but this time you don't have a diagram, you have a table. So we'll just read what it says in front of us. Alright, the table below shows whether each of the given numbers is an element of the natural numbers, n, the integers, z, and the rational numbers, q, and the irrational numbers, r/q. So something that we haven't sort of seen before, but r/q means in sets notation. So the long way of writing this would be your real numbers without your quotient. So in other words, rational numbers. So real without rational. And you might think, well, what does that actually mean? What would that look like? If we go back to the previous question, this one here, or I might go to the marking scheme because it's a bit neater. The real numbers are all the ones on your outside, and the rational numbers are all the ones in here. So if we were to think about the real numbers, without the rational numbers, without those, all we would be left with is these guys here. So in other words, your irrational numbers. Irrational numbers. So this part here asks us whether each of these four numbers here, whether they are irrational or not. The other three things here, you know what they mean from what we've gone through before. So just something to be aware of. And again, once I do my video on sets and sets notation, we'll have a look at that bit there again. So we've got to complete the table by writing yes or no into each box. And one row is already done for us, so we'll just make sure that 16 is correct. 16 is a natural number. It is an integer. It is a rational number. It can be written as 16 over 1, but it's not irrational. 16 doesn't have a load of decimal numbers after it that keep going, so it is not irrational. So put a little tick there. So that was just to make sure that the question there is finished, and just to like recap ourselves, just to make sure that we're okay with what this question is asking us. Okay, we'll try root 6 ourselves. And we need to ask ourselves, root 6, well, is it a natural number? Well, it's not a natural number. A natural number just are positive whole numbers. So we're going to say no. Is it an integer? Well, integer are positive and negative whole numbers, so no. Can it be written as a fraction? Q, quotient, which means something divided by something, which means a fraction. Can it be written as a fraction? Well, you might say root 6 over 1, but root 6, if you put that into your calculator, you are not going to get a nice looking number. In other words, you're going to get a number that has a big long decimal outside it, and your calculator will not be able to put it into a fraction for you. So it's not a fraction. Can't write it as a fraction. And then we just got to be careful here. Well, is it irrational? Well, if it's not rational, so if it's not part of Q, then it must be irrational. So we're going to say yes there. You'll notice that for the last two columns here, if you just look a bit closely, like Q here is rational. This one here is irrational. And you can't have a number that's both. So if we put like yes in this box here, then we cannot put yes in this one as well. So just something to be aware of. Might help us out in our next two questions. Okay, 2 over 3. Is it a natural number? It's not. Is it an integer? It's not. And the reason for that is it's a fraction. It's not a positive or a negative whole number, which are what we're dealing with for our integers, and it's not a positive whole number, which is what we're dealing with our natural numbers. Can it be written as a fraction? So can it be written as, is it an element of Q? And the answer there is yes. It's written as a fraction already. 2 over 3 is a fraction. So if it can be written as a fraction, well, is it irrational then? Well, it's not irrational, so we're going to say no here, because of the fact that it can be written as a fraction. So again, just going back to what I said there, if I've put in yes in this box, well, I have to put no in this box here. Okay, last one, -4. Is it a natural number? It's not, because it's a negative. Is it an integer? Yes, it is, because it's a negative whole number. Can it be written as a fraction? Yes, it can. -4 all over 1 is a fraction. So if it can be written as a fraction, well, then it can't be irrational. So we're going to put no here. So the main thing about that question there was to take a deep breath and sort of just look at what the question is actually asking you. Take it row by row or column by column if you wanted to, but just one bit at a time, and just make sure that you're happy with your answer before you put that in. This is what the marking scheme looked like for that. And our answers, those were our answers. and they match up perfectly with what we've done just up here. Just looking at the marking scheme, obviously your 10 marks for getting all those correct. Your high partial credit, which was your 8 marks, if you got 2 rows or 2 columns fully correct. So basically, if you got in that box there, that would be 2 columns. If you got all of those correct, then that means you're getting 8 marks, even though you got, let's say you made a mess of those, that part there. You're still getting 8 marks, which is 80% of the whole question, and you've only answered half of it correctly. So they're basically firing marks at you there. 1 row or 1 column fully correct would have gotten you 6 marks, and 4 answers correct. So you notice that there's 12 possible answers you could have given. Let's say you got 4 of those correct. So 1, 2, 3, 4. Even if you were to guess those, it would have been very hard, like, not to get a few marks in this question. It was a very handy one to get your 10 marks in. And all it came down to was your definitions, and were you able to decide, well, was a number natural number, an integer, a rational number, an irrational number, and you knew anyways that they were all going to be real numbers, because that's all we deal with at Junior Cert. Okay, there were the 2 questions I wanted to go over. One with a diagram in it like that one, the one from 2012, and one with a table that came up in 2017. Both of those are popular ways of the question coming up in an exam question. So just to finish off, your key points. I suppose I've taken this from one of my other videos, but the main thing here are that part down there, and I will be copying and pasting that into the description below. And also, just while we're here, if it says that x is x and then that e symbol, that means x is an element of. So that means that whatever number you're dealing with, it's an element of, it's part of these sets down here, the ones that we're just after looking at today. So your sets that will come up are your natural numbers, your integers, your rational numbers, which can be written as a fraction, your r without q, which are your irrational numbers, so your real numbers without your rational numbers, and then your real numbers, which is anything that you can think of. So basically, those 2 exam questions that we had to look at, that one and that one, all came back to your knowledge of this. And there's quite a lot of marks going for those as well. Alright, I think I've gotten everything covered there that I wanted to. If I've missed anything, I'll put it in the description. But for now, that's all we're going to do for today. Thanks for listening.